Now that I've stopped and started recording. Um, Anderson, you wanted to go first. Could you please share your screen and then you can begin your presentation? Sure. There should be a green button on Zoom to let you do that. You open it up. Did you start sharing your screen and then you can open your presentation in PowerPoint? Okay, Pablo, you can go. Sorry, I was just trying to check some things. Feel free to share your screen and start your presentation. You will need to unmute.
Got it. Let me just get to a quieter room real quick.
Mhm.
Hello? Can you hear me?
Yes. Can you share your screen?
Yep. I'm just sitting down right now. Okay. Share screen. All right.
Okay.
All right. Is it presenting? Presented?
Just a second. It's lagging a little.
Oh, I apologize.
There we go.
All
Not
right.
your problem. Yeah.
Okay. So, no, my topic is about if astronomy can be seen through comic books. Now, astronomy is something that we see all around us. Even looking at the sky is part of astronomy. But one form of media that uses astronomy the most is comic books, mainly from the likes of Marvel. There are many characters or teams that get their powers because of the solar system. They could be getting it from exploring space, seeing the multiverse, or even protecting it from beings that want to rule it or eat it. Comic books help readers see the amazing and fascinating world of astronomy, or even just a glimpse of it. Now, Marvel has had astronomy in their comics for decades, even when they were called timely comics. Now, it all mainly began with the Fantastic Four, which, in my opinion, has one of the most representation of astronomy in comic books. The first pieces of astronomy from there is how they get their powers. Now, in the comics, especially from issue 1, the team went into space and ended up getting their the team went up into space and ended up getting caught in cosmic rays, high energy particles that travel through space at the nearly speed of light and operate from the sun, the Milky Way, and other galaxies. Now, the four were bombarded with these high energy particles, hence granting the team with their powers. But one interesting thing actually is that it actually kind of is inaccurate. As you can see right here around the third panel, is this say right here, they just say they're only rays of light, which obviously isn't true at all. As because they are high energy particles, primary atomic nuclear protons. Sorry, I'm trying to look at my slides, but there we go. We'll just say right here instead. Through space at nearly speed of light, and they would obviously hurt like hell. I'm trying to see where I am. I have my script. Sorry. Now, with their powers, they have the responsibility to not only save the people of the Earth, but other forms of life from different planets and different universes. Through all their unique powers, there is one that actually interested me the most, which is the Human Torch, also known as Johnny Storm. The Human Torch has the ability to control fire and transform himself into, well, a human torch. Now, Johnny can also control how hot he gets, which leads him to one of his sayings called, or is, supernova. When he says this, Johnny's temperature becomes greater than a supernova. Remember, a supernova's temperature is billions of degrees Celsius or Kelvin, which is significantly hotter than the sun itself. One of the biggest foes of Fantastic Four to have to fight is, in fact, Galactus. Sorry, Galactus, a cosmic entity known for eating worlds, quote unquote. Though he doesn't actually eat planets, he uses a machine that turns a planet's energy into one he can use for himself. Now, obviously, the energy from a planet is stored inside its core. Now, Galactus chooses planets based on the specific cosmic energies they contain, often seeking worlds with potential for life, not necessarily life itself, to fuel his cosmic power. Now, there are a few more teams that do also have astronomy seen through it. Here we go. Here we go. Yep. The Guardians of the Galaxy are another team that explores space and protects the galaxy. I mean, that's what the Guardians do after all. Even the leader's name references astronomy in some form or way. Star-Lord. Speaking of the leader, in the movies at least, he is in fact a planet, which sounds weird, but that's comics. Though his father doesn't fall under any type of other planet like Terrasa. I always forget to pronounce that word. Planet. He's a living planet with a brain as its core. Now, the Avengers aren't just Earth's mightiest heroes, but also some of the mightiest in the galaxy. From time to time, we have seen this team go into space, sometimes even, fighting who knows what, from aliens to titans to even gods in space. It's crazy. I'm trying to look where I am. Here we go. Now, there are other characters that also do have astronomy in a way to kind of help them. Here are three more here. So Moon Knight's powers comes from the moon god Khonshu. Now his powers are also tied to the lunar cycle. Basically meaning the more the moon is exposed, the more powerful he gets. Captain Marvel is also a hero who protects the galaxy, even gets their powers from cosmic energy. And through other comics, they have gone to different universes, different galaxies, and whatnot. The final one on my little list right here is Silver Surfer, which is another hero that helps protect the galaxy, as he has seen betraying Galactus to save countless lives on different planets. Just a little thing, heads up. Silver Surfer is basically like Galactus's helper. He is one who seeks all these planets with rich power. Final two examples are Thanos and Magneto. Now, Thanos is an alien from Titan. In the Marvel Universe, Titan is one of Saturn's moons. Now, Galactus is known for having an infinity gauntlet, which lets him control the aspects of existence, that one of them obviously being space. Magneto possesses the ability to manipulate metal and other ferromagnetic materials. meaning he can manipulate magnetic fields around him. Now, my conclusion: can astronomy be seen through comic books? Yes, but probably not the best source to get information. And remember, it's a comic book. Of course, like everything's to be true or accurate to our world. I mean, could people really be exposed to exposed to cosmic rays and get powers? Sadly, not. But I will say, comic books do help open the doors. Get people interested, get people hooked onto astronomy. That leads them into looking more into it and whatnot. That concludes my presentation.
Thank you. You can stop sharing, or I guess I can probably
Yep.
end it.
Did I stop?
Yeah. Let
All right.
me-
Thank you.
Okay, let me just. So Anderson, are you still having trouble? Um, well, if Anderson's still having trouble, um, Sunam, you offered to go next. So, so you can go next. Feel free to share your screen.
Um, can you guys see my screen?
Yes, let me. Okay. Um,
Hello, so today I would be presenting the search for exoplanets and strange worlds beyond our solar system. Um, so what are exoplanets? Are planets that orbit stars beyond our solar system. For a long time, scientists were unsure whether other stars even had planets, but that all changed in the 1990s when astronomers confirmed the first exoplanet discoveries. Since then, thousands of exoplanets have been identified, showing that planets are very common throughout our galaxy. Why are exoplanets hard to detect? Exoplanets are extremely difficult to detect because they are very far away and much dimmer than the stars they orbit. When astronomers look at a star, the brightness of the star overwhelms the light from any planets nearby. Because of this, scientists usually cannot see exoplanets directly and instead look for the effects that these planets have on their stars. The transit method. One of the most successful ways astronomers detect exoplanets is called the transit method. This occurs when a planet passes in front of its star and blocks a small amount of the star's light. By measuring these tiny dips in brightness, scientists can determine the planet's size and how long it takes to orbit its star. Telescopes such as Kepler and TESS rely heavily on this method. Another important method used to detect exoplanets is called the radial velocity method. As a planet orbits a star, its gravity causes the star to move slightly. This creates a wobbling motion. Astronomers detect this movement by observing changes in the star's light spectrum. This technique helps scientists estimate the planet's mass and better understand its orbit. Types of exoplanets discovered. One of the most surprising aspects of exoplanet research is the wide variety of planets scientists have discovered. Hot Jupiters are large gas giants that orbit very close to their stars and experience extreme heat. Super Earths are rocky planets that are larger than Earth but smaller than Neptune. Some exoplanets may be covered entirely by oceans, while others are so hot that rock could melt on their surface. Strange and extreme worlds. Worlds. Many exoplanets are far more extreme than anything found in our solar system. Some have lava oceans due to extremely high temperatures. Others experience powerful winds moving faster than the speed of sound. Scientists have even discovered planets that may have clouds made of glass or molten metals. These strange environments challenge previous ideas about what planets can be like. A major reason scientists study exoplanets is to search for potential life beyond Earth. Astronomers focus on planets located in what is called the habitable zone of a star. This is the region where temperatures may allow liquid water to exist on a planet's surface. Because water is essential for life as we know it, planets in the habitable zone are considered promising candidates for further study. What we have learned about life beyond Earth. Although scientists have not found direct evidence of life on exoplanets, these discoveries suggest that the conditions needed for life may be common in the universe. Many Earth-sized planets have been detected, and habitable zones appear to exist around many stars. Studying both habitable and extreme planets helps scientists better understand where life might exist and where it cannot survive. Conclusion and big question. In conclusion, the search for exoplanets has greatly expanded our understanding of the universe. Using methods such as the transit and radical no racial velocity techniques, astronomers have discovered thousands of planets with a wide variety of characteristics. These findings show that planetary systems can be very diverse and that Earth may not be as unique as we once thought. Ultimately, the study of exoplanets brings scientists closer to answering one of the humanity's greatest questions. Are we alone in the universe? These are my sources. Thank you.
Thank you. Um, so next, let me just go over who's here. Uh, yeah, Anderson, you can go now.
Could you hear me?
Yes.
Did you see my screen?
Yep.
Okay. My topic question was to find a star that we could look at in the sky and find out information about it and find out what it would be like to live on a planet orbiting around it. So this is about a star series. When the night sky gets dark and the stars start to show, one of the easiest stars to spot is Sirius. It's the brightest star we can see, and you don't need a telescope to find it. It basically jumps out at you. Sirius is part of the constellation Canis Major, and people have been noticing it for thousands of years because it's so bright and well known. It's a great star to compare to our sun and to imagine what it might be like to live on a planet orbiting it. Sirius is actually pretty close to us in space, only about 8.6 light years away. That still sounds huge, but compared to the size of the Milky Way, it's not far at all. It looks bright partly because it's close, but also because it's just a more powerful star than the sun. Sirius A, the main star in the system, is almost twice as hot as the sun and also bigger and heavier. Because of this, it shines about 25 times brighter than the sun does. But stars that burn hotter and brighter don't last as long. While the sun will live around 10 billion years, Sirius A will only last a much shorter time. So even though they are both main sequence stars, they're really not similar. If we imagine a planet orbiting Sirius, it would have to be much farther away than Earth is from the sun to avoid getting fried. If it were at Earth's distance, it would be way too hot and full of intense radiation. A planet would need to be 2 or 3 times farther out just to have temperatures like ours. Even then, it would still get a lot more ultraviolet radiation, which could cause problems for any life trying to survive there. The kind of atmosphere the planet had would matter a lot. There's also another big complication. Sirius is actually a double star system. Sirius B, the smaller star, is a white dwarf, a leftover core of a star that already died. It's not very bright anymore, but it's extremely dense and has a strong pull that could mess with the orbits of planets. Some orbits in a system like this can be stable, but others get thrown off, which makes it harder for life to develop over long periods of time. Still, it's fun to imagine what living on a planet around Sirius would be like. Days would probably look brighter with a different tint to the sunlight because Sirius is a blue-white star. Life there might need thicker skin or special ways to handle the harsh radiation. At night, you might even see the little white dwarf star, Sirius B, glowing like a tiny bright speck in the sky. The seasons and length of the year could be different too, depending on how the planet orbits. And because Sirius won't live nearly as long as the sun, life wouldn't have as much time to evolve into complex forms. Thinking about Sirius shows how different stars can be and how special our sun is. Sirius is beautiful to look at from Earth, but it would be a much tougher place for life to exist. Imagining a planet around it helps us appreciate how perfectly balanced Earth's environment really is and how many different kinds of stars fill our night sky. Thank you.
Okay,
Wait, how do I stop sharing?
you gotta zoom in.
Ah,
Yeah. Um, yeah. Uh, Cooper, you wanted to go next? Um, so Cooper, feel free to share your screen.
Yeah, I wanted to go next because I have to go soon. So, just my presentation, right?
Just your presentation. Do your presentation.
All right. Uranium, the underutilized radioactive.
You need to share your screen with your slides.
Am I not sharing it?
No. There's a big green button at Zoom.
The entire screen. The Chrome tab. All right. I'm sharing it now.
Yes. Just a second. Yeah.
Uranium, the underutilized radioactive applications now insidious ups. I cannot see it well. Uh, Insidious modern Modern moderation. Sorry, it's like the apps. Hold on, I closed it. Okay, the long history. Uranium was discovered in 1789 by German chemist Martin Heinrich Klaproth at the ripe old age of 46. He discovered uranium by finding an oxide of it, uranium dioxide, when he was trying to study uraninite, a rock where uranium is commonly found in. Uranium was isolated in metal form by a good Monsieur Eugene Melchior Peligot in the mid-19th century. We only knew uranium was radioactive when one other monsieur, Mr. Henry Becquerel, misplaced it on top of a wrapped photographic plate. For anyone born after Donald Trump, photographic plates were a way to take pictures before film. They were composed of silver crystals, and when exposed to light, the light changed the structure, and then chemicals were added so the image became visible. When Henry returned, the plate was foggy. He theorized that the uranium left off little penetrating beams because of its fogginess, and thus radiation and uranium's radioactivity was discovered. Underutilization. When I say underutilized, I mean in the prospects of peaceful purposes. Nuclear power plants, mostly uranium-based, only make up 9 to 10% of our total electrical production. 9 to 10% despite it being quieter than wind, cheaper and cleaner than coal, more accessible than geothermal or hydropower, cleaner than biomass, more compact than solar, less temporally limited too. Its only caveat is that it's not totally renewable, though technically a lot of nuclear waste can be reused. It's not like we will run out of uranium because it's a pretty common metal on Earth. Uranium weaponry is also not considered enough. Uranium bullet made of depleted uranium are common in anti-armor rounds because they're dense and puncture metal like a knife to a banana. Uranium can keep peace by making it. Radioactive. Uranium is radioactive. Radioactivity can be very useful and very harmful. In nuclear power plants, uranium-235 is split into two atomic nuclei, releasing a thermal energy and a gamma radiation, which is ionizing. The heat generally turns the water into steam, spinning a turbine, and makes electricity. In the human body, radiation emitted from uranium-235 can knock electrons from DNA, sometimes even breaking DNA strands in half, causing small mutations and errors that accumulate. The amount of uranium-235 someone can hold without getting damaged is zero of any weight measurement. I guess I should mention uranium's atomic structure. Uranium has 92 protons, 92 electrons, and for uranium-238 specifically, it has 146 neutrons. Uh, Applications. Nuclear power. Uranium-235 is harnessed in nuclear reactors to make power. Uranium rounds. Uranium is dense, so I think we shouldn't just use this in armored rounds, but in anti-armor rounds, but in standard rounds to make more peace. Uranium tonics. Uranium can be used in alternative medicine. Imagine uranium gummies. Uranium pigments. Uranium is a really pretty silver color. It'd make a nice pigment. But now, in the modern day, uranium is often found in depleted uranium rounds in armor. The M1A2 Abrams armor plating contains depleted uranium because it's so dense. It also shoots uranium rounds, including the MA2A29 series. Despite uranium being well known for its use in nuclear bombs, it is no longer a whole mechanism because it is more efficient to just fuse hydrogen to obliterate a city. Uranium is mostly just a trigger mechanism. Uranium is nowadays referenced in modern media like the Fallout series, Pokemon Uranium, StarCraft, Star Wars, and Idle Mastermind. The Insidious. Nuclear power plants accidents kill thousands long term. Uranium's radiation emissions are ionizing, meaning they exist on the spectrum of radiation that can strip electrons off atoms and off you, increasing the risk of getting cancer. Depleted uranium used in conflict killed hundreds. Nuclear bombs, the ones used in Hiroshima and Nagasaki, killed around 250,000 people. Uranium poisoning. Uranium is not just radioactive, it is toxic. Worse yet, it imitates calcium, so not only do you have one interaction, you have a little thread inside your bones releasing whatever it wants, whatever it releases into your body. Uranium body has killed thousands. It has caused lung cancer in the miners who inhale the ugly stuff in the mines and call it a paycheck. Ups. Uranium can help us in the fight against climate change because it doesn't make carbon dioxide in a vacuum since it's uranium. Uranium can help us build our might against soldiers who wish to knock on our doors. Uranium is a pretty poor conductor, and it's very hard to melt. With a melting temp of 1,135 degrees Celsius and a boiling temperature of 4,131 degrees Celsius. Being a pretty poor conductor, it can keep an area warm, which only despite taking up hundreds of degrees earlier. Moderation. Uranium has so many restrictions and regulations on it. It's basically treated as a Schedule II narcotic. Nuclear power plants need multiple fail-safes. Hundreds could die if one were to fail, meaning a 1% chance of failure per reactor is too high. Uranium mines are often heavily regulated. A lot of lung cancer can occur without these regulations, not because of the uranium, but because for some reason there seems to be a lot of radium next to the uranium. Um, and that radium breaks down into radon gas, which is toxic. Nuclear waste can be stored in has to be stored in a cask for the rest of its eternity. It generally falls under three categories: low-level waste, intermediate-level waste, and high-level waste. These three categories are defined by three different exposures to nuclear fuel, stated in order: contaminated items, components, and used-up fuel. The higher, the more intense the storage. Good riddance to this slideshow.
Okay, thank you. Um, so, uh, let's see, who is next? I guess I can just go through who is here. Uh, let's see, Damien or Daniela. Yeah, you'll be actually the next person I would mention, Jose. Jose, you're next. Um, Cooper, you presented, so you're done here. So Jose, you are next on the schedule.
Is my mic on?
Yes, I can hear you now. Please share your screen.
All right, I think I'm sharing.
Yes. Mm,
Okay. The Origin and Fate of the Universe by Jose Ramirez. The most
uh,
common and used theory of the universe is origin is the Big Bang Theory. The Big Bang Theory proposes that the universe came to life around 13.8 billion years ago. While many believe the Big Bang was a big explosion, hence the name, it was really the rapid expansion of space itself. All the space, time, matter, and energy that we know of today was compressed into a tiny, hot, and very dense space called the singularity. When it first started expanding, that was the starting point of the universe as we know it. The timeline of the universe's existence goes as follows. It went from a singularity to an intensely dense, flaming soup of fundamental particles. It started its rapid inflation with separated forces like strong matter, weak matter, gravity, and created protons and neutrons from quarks and all on the first second. In the next 2 seconds, it started creating the basic elements of life, hydrogen and helium. The universe is constantly expanding and cooling down. After around 3 minutes, the first atomic nuclei was able to form, made up of mostly hydrogen, but also helium and lithium. This process is known as the Big Bang nucleosynthesis. and was the first chemical composition in our universe. The first formation of difference in structure was possible because of gravity. The early stages of our universe had an almost uniform structure of matter, but the tiny, almost unnoticeable differences were the birth of what the universe structure is now. Gravity came into the equation and started pulling on these slight differences in density. This caused the denser areas to grow denser, which ultimately turned into clouds of gas that formed the first stars along with galaxies. For billions of years, lots of evolution and merging happened to create galaxy clusters, superclusters, and the cosmic web. In order from smallest to largest. The heat death ending, also known as the Big Freeze, is a theory that our universe ends in a cold and dark state because of its expansion. The theory suggests that stars will burn out and stop shining. After this, galaxies will spread so far apart due to dark energy and will eventually be unreachable. Stars will stop being created and black holes will slowly be gone. After this, protons will start decaying along with any remaining matter, leaving no energy to fuel the expansion of the universe. The universe gets its energy from the difference in matter. If this happens, the universe will be equal all around and there will be no energy left to expand. If there is no expansion happening, there is no life, and this will eventually lead to a cold world, hence the name the Big Freeze. A cold world where no life could be sustained. That's my presentation.
Okay, thank you.
Wait, how do I stop presenting?
I'll go to Zoom and just stop sharing, or there should be a stop sharing button. Um,
Do I put pause?
Just a second. I
Oh,
can.
wait.
There
Okay.
you go. So since Daniela and Damon aren't here, next on the schedule is Julissa. Let me pull your slides up for you. Let me share my screen.
Here are some of the unique experiments.
Just a second. Here, and the down arrow goes to the next slide, up arrow goes to the next slide.
Here are some of the unique experiences on the moon. The moon's environment is completely unlike Earth's. Because of that, the moon opens a lot of strange abilities that you would not be able to experience on Earth. Here are a few. On the moon, you are able to move in slow motion without even trying. This is due to the moon only having 1/6 of Earth's gravity. If you jumped, you would go way higher and stay in the air longer than on Earth. The gravity on the moon also affects what you can carry. Therefore, on the moon you can lift objects that would take a machine to move here on Earth. Yet the object does not lose its mass. On the moon you can leave footprints that can outlive entire civilizations. This is because on the moon nothing naturally erases marks left on the surface. Because there is no real atmosphere on the moon, sound does not travel the way it does on Earth. If someone was standing outside someone's spacecraft, they wouldn't hear wind, footsteps, or even hear someone talking to them unless they were connected to radio. Lastly, on the moon, the sky remains pitch black, even when the sky is shining. For that reason, you could see the stars and the sun at the same time, which is impossible here. In conclusion, the moon is a place where the rules of everyday life are completely
Stefan. Um, Let me inception. Just a second. Okay, um, let's see. Going through. Don't see Damien. And then nor do I see Daniela. So that leaves Pablo Tovar. Yeah, he's still taking the test. Okay, so um, that's everybody can go for now because Damien and Daniela are here. Everyone, make sure you send me your slides. Because I know at least some of the people who presented today, I don't have your slides. Um, just looking at that. And I will hang out here in online, but because we went through pretty much everybody, you guys are free to go. Yeah. Can you check it right? You're missing residence? You are. Yeah, I got yours. Okay. Let me just. Yeah. You did yours a while ago. Yeah, I have yours. The only people who went and I didn't have their slides are people who went today. I mean, if you presented in class, I definitely had your slides. Okay. Yeah, so I'm gonna have in uh, the meeting, I'm gonna be here till the end of class and I'll give people a chance to do the presentations. Yeah.